we're starting lesson 3-7. 3-7, which is dealing with solving inequalities. So again, inequalities being a key word in this chapter, by multiplying or dividing. Okay, so have we dealt with multiplying and dividing equations? Yes. What we haven't dealt with is, in our class, inequalities, which is going to be super important, okay? Everything's going to be the same except for one major part, okay? And I'm going to try to emphasize it as much as I can. If you're paying attention, you should get it. If you're not paying attention, why should you expect to get it? So I want all of you right now to think to yourself, and just don't give me the answer out loud, am I doing my best to pay attention in class? And then you answer that before you and the Lord. Don't answer it to me. I just want to help you out by helping you reflect on that. Okay, let's look at an inequality here. 35 is less than 64. How many of you would say that's true? 35 is less than 64. You guys say it's true? Good. Hopefully all of you say it. So I'm going to put here true. What happens if I multiply these two numbers, or both sides of an inequality, by the same number? So I'm going to do 35, and you can write this down, 35 times 4 and 64 times 4. Okay, we're going to multiply both of those and see if you can get it. You can try it mentally, you can work it out, but figure out what 35 times 4 is, and then what 64 times 4 is. Okay. How many of you would agree that 140 is less than 256? Okay? And is that what you got for 35 times 4? If you worked it out, 64 times 4, okay? So I'm going to write here, still true. Still true. And I'm going to put a little exclamation point. That's good. So how about this? I'm making a generalization off one problem. If you have an inequality that's true, and you multiply both sides of that inequality by the same number, right? What do you still get? A true inequality, right? You guys okay with that? That's very important. Okay, let's do another one here. Let's start with 140 is less than 256, okay? Is that true or false? True. So I'm going to put here true. Okay, so this is another example. It's going to show you another idea. What if I divide both sides of this inequality by 2? Well, what do I get? Figure that out. 140 divided by 2 is, and 256 divided by 2 is? Okay, how many of you got 70? And if you were able to work it out, 128? Okay, or maybe not. Maybe I didn't give you enough time, but the whole point is, can you get 70 and 128 if you divide both sides by 2? Okay, good. Is this still true, or is it false? It's still true. Very important, still true. Like, Mr. A, what are you getting to? What are you getting to? Well, I'm going to get to the first property of multiplying or dividing inequalities. Okay? So here it is. This is the key thing I want you to get. That's an asterisk. You can think of it as a star. This is something important. Multiplying or dividing both sides of an inequality. And then there's a key phrase here. By a positive number. And I'm going to do this for you. I'm going to underline positive number. Okay, write that down. And then underline for yourself positive number. Because I'm going to give you another one of these notes. And it's going to say everything the same as the first line, second line, but the third line is going to be different. Key difference. So what happens when you multiply and divide both sides of an inequality by a positive number? Well, what happened here when you divided both sides by 2? You had a true inequality and it was still true. What happens when you multiplied both sides by a positive? You started with an inequality that was true and it was still true. You guys good with that? That's important. Okay. I think I'm going to leave it that way. I had more notes to give, but I think it's going to get too technical. Let's just start with an example here. Go to example 1. So I think you got to turn the page. Example 1A. I'm going to look at example 1A. I'm going to look at that one first. All right, that one's 4x is less than negative 28. Okay. Yes, sir? Oh, let me get that for you. 4x is less than negative 28, okay? This is a review of what we looked at yesterday. It's going to be looking for the variable, finding out what's happening to that variable, and undoing it, right? So you have like 3 steps. Where's the variable? Yeah, it's right there, right? Good. It's an x. What's happening to the variable right now? Tristan?
Being multiplied by 4.
Okay, everyone okay? You're multiplying it by 4. What undoes multiplication by 4? So what do I do to both sides of the inequality, Josie? I'm going to divide both sides by 4. Okay, that's super important. And I remember when I brought this up for the first time, when you do something to one side, you got to do it to the other. Maybe some of you are thinking, Mr. A, you really don't have to do that. I'm like, yes, you do, because this is where it's going to play a more critical role. Okay, so what do you get here? What's 4x divided by 4? X. And then I have less than. What's negative 28 divided by 4? Negative 7. Remember, a negative divided by a positive is negative, so negative 7. How many of you got x is less than negative 7? You understand that? Do you guys remember our graphs? Okay, so here, we're going to draw a quick graph. It shouldn't take us long, just a little number line. I'm going to do negative 7. What should go here? Negative 6. And what should go over here? Good. So please remember that with negatives, it's like reverse thinking because you're getting smaller and smaller as you go to your left. Okay. Now the question is, what kind of circle should go right here? Raise your hand. John? Why open?
Because the open circle means that when you put the arrow, closed circle means if it's equal or less, equal to less than or greater than.
Okay.
And the open circle is meant greater than or less than.
Okay, so let me kind of summarize that. Is there an equal to sign here?
No.
It's open. If there's an equal to sign, it's closed, right? And then you're going to see it practically why it wouldn't work if you did close it, and vice versa for the other situation. Where should my line go? So I have a starting point, and then where should the line go?
To the left.
Very good, to the left. And you got to make sure that it's clear. Like if this line looks exactly like that line, it's not clear. So I just make it a little bit darker. And don't go too extreme. I know you can just like, really show it off, but just try to make it clear. Okay, sorry.
These four cancel each other out, right?
Yeah, and I didn't put that there, but yes, it would do this. Yep. And you're left with x. Yep.
I did like just like an arrow above the other arrow.
Okay, so what I would say there, Jack, and that's a common thing, is get used to doing it like this. So I think what you did was something like that. Yeah, try to stay away from that, because what you're going to notice is that on future problems in this lesson and in other books or other classes, they're always going to do it this way, so just get used to it, because you'll be comfortable with it. Are you guys okay with this? How do we check our answer on this one? You look at the line, looks good. Marissa?
You could add any number, multiply any number that's less than negative 7.
Okay, so negative 8, is that a good one? Should it work? According to my graph, it should. Okay, what's 4 times negative 8? Negative 32. Is negative 32 less than negative 28?
No.
Yes, remember negative 28 would be here, negative 32 would be over here. So it is true. Now, should negative 6 work? No. So let's see. What's 4 times negative 6? Negative 24 is less than negative 28? No. You got to think through that because wait, they're negatives. Negative 24 is greater than negative 28. All right, but what about negative 7? What a hard number to be in this problem. Negative 7 is so close to the answer, but it's not. But I need to check it out. What's 4 times negative 7?
28.
Negative 28? Is negative 28 less than negative 28? No. A number is not less than itself. A number is equal to itself. That's why if it doesn't have the equal to sign, it's open. If it does have the equal to sign, it's closed. It's rational. All right, how many of you kind of get this stuff? You're like, okay, I'm not too bad on this. Good. On page 154, I want you guys to do number 5. Oh my, what did they do to that inequality? They switched it on you. Don't read those instructions. I'm not having you do that right there. Just solve for A and graph it. So number 5 on page 154. And if you need help, I'll work it up on the board. If you don't, just do it on your own. Some of you are thinking, I don't like that A on the right side. I can't stand that variable over on the right. And I understand that. You can move it to the left as long as you keep it in the right inequality. Okay, but does anyone know which side should be bigger? Which side should be bigger? The right now or the left? What do you think? What should be bigger?
Negative 15. Wait.
So where does that arrow point to? It points to the smaller number. Therefore, 5A should be bigger. Does that make sense? It opens up to the bigger number. All right, ready? Watch this. Which one's bigger?
5A.
So did I change which one was bigger?
No.
No, I changed the direction of the sign, but that's only because I changed the order here. Okay, so I can work it out now very easily. Okay, I'll do this. Can someone come up here and show me what to do? John, come on up. Use any marker. Show me all the steps appropriately, and then I'll have someone else do a graph. So you can do this one out. Right here. Oh, and don't forget your graph. Get a graph. Put a graph with the number line.
The graphs are hard, because I don't know which way to go.
Yes, I'll help you out with that.
That's like the division symbol. That's like the division symbol.
Yeah, and when you put that little fraction bar, it means that number up top divided by the number below.
Yeah, why did you put it under
The inequality sign, I think that was just we went a little bit far. Okay, how many of you got A is greater than or equal to negative 3? Okay, so your inequality is good so far. Who can come and do that graph for me? Callie, come on up. You can do it with a different color. How about that? You have 3 awesome colors to pick from. Blue, red, and black. Oh, she picked blue. Good.
That's purple.
Yeah, I guess my blue's turned to a little bit of a purple, which is cool. It's changed. Okay, good. Thank you, Callie. And I'm going to say, just make this a little bit more clear that it's this arrow, and then you're all set. All right, how many of you got closed circle on negative 3 with the line going to the right? Okay, how many of you worked it out from here and got negative 3 is less than or equal to A? Okay, so negative 3 is less than or equal to A. Okay, so you got that. Why would this still be the correct graph to display that inequality? I mean, the arrow is going that way. What's happening here? Jack?
It's negative 3 is like less than or equal to a little dot, and then.
Okay, so you got that dot still where it belongs.
And since it's greater than, you have to go this way.
Okay, yeah, if you're looking at like this and you're thinking A is bigger than negative 3, or you can just rewrite it like that. That's the same inequality, okay? And so that's why you would point it to the right. Remember, if you want to use that trick with where the arrow's pointing, the variable has to be on the left. If it's on the right, don't follow that arrow or just go opposite, but even that tricks people. So just make the variable go on the left, you can see it clearly. Ma'am? So
I'm still confused. So if it's a greater than, the arrow would go to the right and it's a closed circle?
no. When do we know if it's open or closed? Can someone help it? So listen up to this answer. Yeah, Michael?
If it has the little line underneath saying that it's equal, that it can't possibly be equal.
So you see here, if it has that little line, whether it's greater than or less than, if it has that little line, it's a closed circle. If it doesn't have that little line, it just has this or the less than symbol, it's open. That tells you if it's open or closed. Jensen?
Another arrow there. I always thought it was like.
Yeah, I would say and I think this is what Callie's trying to do. So she's doing this, and then she basically did this. Yeah, so that's why I told you guys, make it clear. Like, these should not be the same arrows, because then it's saying, oh, it's going both ways, which answers could be that way, and we're not saying that in this problem. Yes, ma'am?
If you have the greater than or less than equal to sign, and the number is equal to that number, would you just put the dot there on the number?
Whatever the number is. Yeah, and close it. Close circle. Yes, if it has that equal to sign, it's got to be closed, always. Okay, yes, ma'am?
Like, why is the line different on arrow? Like, on the arrow, why is it the other side?
Why is that different? Because it's saying that all these numbers are part of the solution. These numbers are not. Like -4, does it fit in here? It shouldn't. Does -2 fit? It should. -1, 0, 1, 2, 3. So it's saying it goes on infinitely. So instead of having to write all those numbers, you just have to draw me an arrow, which is good. Okay, yes.
Why do you switch it?
You switch it for yourself if you need it. Like, if you can look at it this way and graph it correctly, great. But if some people need to see it that way, fine.
But why would you put it? I did it the opposite way.
Okay. Without that arrow.
Yeah.
But you only follow that arrow if the variable was here. And in order to make that happen, just switch it around and keep it. Which one's bigger, the bigger quantity, A or -3? It should be A, right? So here A is bigger than -3. So think through it logically. Don't rush through it and just think it's going to be switched automatically. Yep.
Could you just not draw the tip of the other arrow?
Yeah. You just draw just a segment, and then one side has an arrow.
Yeah.
Oh.
Yeah, that's what Jensen you were referring to.
You have to draw if you have your number line and it's going this way, do you have to draw that side? Or can it
just give me one number before and after, because I still want you guys to practice that. Okay, go ahead and work out number 12. By the way, these are good questions. If you were listening, it may have answered one of your questions. You might have this on that problem or a future problem. So number 12 on the same page. This one just solve for y. All right. Find the variable. Got it. What's happening to the variable? It's being multiplied by 13. What undoes multiplication by 13? Division by 13. So I divide both sides by 13. 13y divided by 13 is y. Greater than or equal to, what's -26 divided by 13? Josie? -2. Good. So -2, that's my inequality. Is the variable on the left?
Yes.
Great. So that makes it easy. Now I just do this. I got -2. I'll put -1 and -3. What kind of circle should go on -2? Emma Grace?
Closed circle.
Closed circle. Why? Sydney?
Because it's saying, if we can 13, times -2 is -26, and it's saying it could be greater or than.
Yeah, it's greater than or equal to. So equal to is why it's closed. And then which way should the arrow go, Tristan?
Should go to the right.
To the right, which means all these numbers after -2, including -2, should be a part of the solution. Yes, ma'am?
On that end, could you put like one of the dots to make it look like a dot? Instead of the arrow, could you put like a circle?
So are you talking about here or over here?
On that. Yeah.
Oh, I see, like a segment, kind of. I wouldn't do that because they might interpret it as a closed circle. Yeah, so just put the closed circle here. You can leave it just empty, like there's nothing else going on. And that's part of a number line. Okay, how many of you got this as your final solution? Good. This wasn't even the hardest part of the lesson. Part 2. Oh, my. Yay, there you go. Good attitude. All right, part 2. Notice I have an asterisk again. That means this is important. So the last 2 examples that you did on your own, you were multiplying or dividing both sides by a positive number. What do you think we're going to do in these examples, Sophie?
Multiply or divide by a negative.
By a negative number, and that changes everything. Multiplying or dividing both sides. Oops, both sides. Probably shouldn't get ahead of myself. Of an inequality by a negative number. It's a curious case here, guys. Underline negative number. That's the key to that second half of the lesson. Okay, here we go. Let's start off with an example. Let's start off with 6 is less than 10. True or false? True. Okay, I'll let you write that down. Give you some more time. So 6 is less than 10. That's true. We have no problem with that. Okay, what if I multiplied both sides of this inequality by -1? So I'm going to show that here. 6 times -1, less than 10 times -1. Okay, what's 6 times -1? -6. 10 times -1? Okay. We did the math right, but there's something up with this inequality. Is this true or false? False. So I'm going to put false, and I'm going to put an exclamation point. It is false. Wait, Mr. A, I thought you're allowed to add or subtract, multiply both sides of an inequality by the same number, and it should be true. We have done that, except for a negative number when you're multiplying or dividing. Okay, so this is false. You guys agree? Watch what I'm going to do here. I'm going to switch inequality sign. So this is kind of like if you're like, I don't know what you just did there. Watch this, ready? -6 is greater than -10. True or false? True. That's kind of like a, huh? Really? I'm not good at emoticons. It's my best smiley face. It's kind of like, okay. Here. Is this false?
Yes.
Yes.
Is that true?
Yes.
So if I multiply both sides of an inequality by a negative number, I need to do what to that inequality sign? Switch it. It needs to go the opposite way. Automatically goes the opposite way, and it makes it true. Now I'm happy. Okay, let's look at an example, see how this works out. Let's go to example 1b. We're still on example 1. Example 1b. Okay, example 1b here. They gave you a problem. Looks really similar to the one we did. M divided by -3 is less than or equal to 4. Okay, so this is back on page 154. I guess it's 153. Okay, you guys see the problem there? All right, look for the variable. It's right there. What's happening to the variable right now? Yes, Mackenzie? It's being divided by -3. What undoes division by -3? Tristan? Multiplying both sides by -3. Notice how Mr. A keeps saying -3. You think that's important? All right, well, let's just do the math right now. Right here, what happens with the -3 and the -3 here? They cancel each other out. You're left with m. What's 4 times -3? -12. Is m less than or equal to -12?
False.
Good, it's false. So what do I do with this inequality? Switch the direction. M is greater than or equal to -12. Why did I switch that inequality? Because I multiplied both sides by a negative number. Yes, ma'am.
Why couldn't it be less than?
Great question. So let's do this, Elizabeth. Keep that question in your mind. She asked, why can't it be less than or equal to -12? Well, let's figure it out. Let's graph this, and then we'll check it to see if it's right or wrong. So graphing it, you got your -12, you got your -11, -13. What kind of circle goes on -12? Everybody? Close. Good. Why? Somebody. Marissa.
Because it has an equal to sign.
Has an equal to sign. It's a closed circle. So that's what guides our closed and open circles. The line should go to the, according to this inequality, to the right. So we'll draw that. All right. Now, I'm going to do 2 numbers to check this answer to see if it's really true. All right. So this goes back to your question, Elizabeth, because I am wondering, wait, are you sure it can't be less than? What number is part of the solution that you can see clearly? -11, right? All right, -11 divided by -3. That's a tough one, right? You could do that math. It's going to be a mixed number. So what's -11 divided by -3? It's going to be positive what? I'll give you some time. So what's 11 over 3?
Is it positive 3 and 66?
Oh, leave it as a mixed number to make it easy. 3 and 2/3. Okay. So is 3 and 2/3 less than or equal to 4?
Yes.
So isn't that a solution?
Yes.
All right, but this one right here should not be part of the solution, right? Let's see. What's -13 divided by -3? Is that going to be positive or negative, by the way? Positive. So 13 over 3 would equal what?
4 and 1/3.
4 and 1/3. Is 4 and 1/3 less than or equal to 4?
No.
So that's why it's not a part of my solution. So if I graph it and I'm like, wait, no, I think that's it, you're going to find out these numbers do not fit. How many of you don't like mixed numbers? Dun, dun, dun. Okay. How about this? My goal is to help you to get better with them, to help you to not be scared of them. Because, honestly, what is going on there? Why can't they just make it into an integer, right? Right? The thing is, that's how life works. In fact, I deal with this too many times to give you only one example, but I'll try my best. When I give money, do I give whole dollars all the time?
No.
No, sometimes you give a bill and they give you something back. They give you bills back sometimes and they give you what? Change. What do I do with this? It's so heavy. You collect it and use it for vending machines. No. What you do is you accept it and you deal with it because things come in parts. Not always the whole bill. They come in parts. Change or bills that you can get as a return for what you pay for. It happens all the time. Money. Money is just one example. Okay. I want you guys to work out on page 154. Workout number 7. And I'll work it out with you if you're not sure what to do. Number 7 on page 154. So it's negative 3m is less than negative 33. All right, so if you need help, you can pay attention up here. If you're like, Mr. A, I have this. Great, then do it on your own. All right, what's happening to m? It's being multiplied by -3. What undoes multiplication by -3? Division by? I'm going to divide both sides by -3. Okay, I agree with that. We've been doing that for a long time now. All right, what's -3m divided by -3? It's just m, because these -3's cancel each other out. That's good. I like that. What's -33 divided by -3? Positive or negative, by the way? Positive. And what's 33 divided by 3? 11. Now, this is where you have to pay attention. Did I multiply or divide both sides by a negative number? Yes. So do I keep that as less than? No, I must switch it. It's m is greater than 11. And you're like, Mr. A, really? I don't know. Let's check it out. 11, 12, and 10. What kind of circle goes on 11, sir? Open, because it says just greater than, not greater than or equal to. And the line, in this case, thankfully goes to the? Right. That is correct. All right, but I'm like, no, that's not true. It can't be true. Well, just pick 12. That's the solution. -3 times 12 is what?
36.
-36. Is -36 less than -33?
Correct.
Yes. So -33 would be right here, and -36 would be over here, right? Because it keeps getting more and more absolute value. So that fits. What about 10? -3 times 10 is? -30. Is -30 less than -33? No. That shows it. It shows that. This is my answer. It has to be my answer. Okay, ready for a trick one, guys?
Yes.
I got you here. If you can do this one, guys, you are set. Number 6 on the same page. Oh, I hope you get this, guys. I really do. Number 6. There you go. I hope you're paying attention. And yes, it's tricky for a reason, and I'm glad we're going to go over it. So y divided by 4 is greater than -20. And I'll give you a few moments to do that. Okay, I need one person per step to help me out. So give me the first step, Braden.
You multiply 4 on each side.
Okay, I'm going to multiply both sides by 4, as Braden said. All right, next step. What happens here? Tristan, what happens here? What do I get?
The 4 cancel each other out, and you're left with y.
All right, so I'm left with y. I agree with that. What happens on the right side, Caroline? What do I get over here?
20 times 4, and I got -80.
All right, we got -80. So far, so good. And the critical key component to this problem. Sydney, what's the inequality sign?
So I think go towards the y, but I don't know.
Okay, all right. That's all right. I'll ask your classmates, see if we can figure this out. Michael? So you're saying y is...
What?
You sure about that?
Yes.
Look at his confidence. Look at his confidence. Now, I need somebody to explain Michael's confidence. How can he be so confident? Josie?
Since it wasn't a -4, it would stay the same.
Okay, what did I multiply both sides by? A positive or a negative? Positive. So did I have to change the direction of the inequality? No. Now, did I have a negative over here? Yeah, but I didn't multiply both sides by a negative. So are both sides important? No. Doing something to both sides important?
Yeah.
Yes. Yeah, because I have to see, what am I doing to both sides? It would be this. And then somebody finish this up. What's the number line looking like? Give me the numbers that go in order. So first, second, third. John.
So it's negative, wait, sorry,
That's okay. Go ahead.
Negative 81 over there. Negative 80 right there. And then negative 79.
Okay, good. All right, Marissa, what's my circle look like? Open circle on negative 80. Line going where, Timothy? To the right. Ta-da. Ta-da. Okay. You guys good on that? Be careful. It's what you're doing to both sides, not what's on one side or the other. Okay, your homework then, and you have like 10 minutes to work on it, which is awesome.
Yesterday we had like 0.
Yeah, 0 minutes. Can I say something here? I'm going to pause Swivl.